Assalamu alaikum and a very warm welcome to everyone. Welcome to Geotechnical Engineering. We're going to be continue with part number 2 on soil consolidation. This is chapter 3 and we're going to continue with part number 2, which is from C6 to C9. Now this is more interesting things that we are going to talk about on soil consolidation. Now, if you remember part 1, we are discussing on a laboratory settings. Means result assumption is being made in laboratory settings. Now we're going to move on to how it relates to the field. That's why we're going to look at C6 on this field consolidation line. So this thing occurs because of laboratory settings. We need to actually make a link between lab and also at site. So that's why we have C6 onwards. Okay, so let's just keep all of this and go to C6. Okay, now the E-log P curves considered in previous section that was discussed previously define the relationship between void ratio, remember void ratio, and pressure. Now let me change to highlighter. Okay, for a given soil, such a relationship is used in calculating consolidation settlement. Now the E-log P curves of figure C4 and figure C10 through the design pad reflect the relationship between void ratio and pressure for the soil sample in the laboratory. So we are discussing about laboratory approach previously. Although an undisturbed sample is used in the laboratory test, it is not generally possible to duplicate soil in the laboratory exactly as it exists in the field. Thus, the E-log P curve developed from laboratory consolidation tests are modified to give an E-log P curves that is presumed to reflect actual field condition. Okay, so this is the first thing that we did, make assumption, and we try to make it simple to actually reflect whatever result from the lab to the site condition. Now this modified E-log P curve is called the field consolidation line. Okay, two methods for determining the field consolidation line follows. One for normally consolidated clay and the other for over consolidated clay. Two types of clay that we discussed earlier. In the case of normally consolidated clay, determination of the field consolidation line is fairly simple. With the given E-log P curve developed from laboratory tests, okay, if you look at figure C13, the point on the E-log P curve corresponding to 0.4 E with a sub-zero is determined. So point F in figure C13. Now let's look at C13. So this is C13 and point F is here. Okay, and this is the field consolidation line for normally consolidated clay. Okay, hope you still remember how to determine a clay, whether it is of normal consolidated clay or over consolidated clay. Now let's go back. A straight line is connecting point A and F. This is gives. Okay, please correct this one. This is gives the field consolidation line for the normally consolidated clay. And this is research conducted by Shertman in 1955. For over consolidated clay, we have another figure. Finding the field consolidation line is somewhat more difficult. Okay, so you got to read all of this. Okay, and I'd just like to summarize this. This point of intersection is designated by M in figure C14. Okay, let's look at this figure C14, and the field consolidation line, if you follow the procedure step by step, is this one. Okay, So this is obtained from laboratory works, okay, loading and unloading, and this is what you're going to define to represent the field consolidation line for over consolidated clay. Okay. Now, of special significance in the slope of the field consolidation line. The slope is called the compression index. You have another term, okay, C sub C, and may be evaluated by finding coordinates of any 2 points on the field consolidation line, respectively, these two, and substituting these values in the following equation. So in order to get CC, you got to make a relationship between these 2 points. Okay. Now, Scampton 1944 has shown that the compression index can be approximated in terms of the liquid limit, LL in percent, by the following equation for normally consolidated clay. So we have another equation to get CC. Okay, this is by Scampton. Now I'm showing you two approaches to get CC. Okay. So that's all about it for field consolidation line. Okay, basically you're gonna know how to plot the points for field consolidation line for two types of clay: normal consolidated clay or over consolidated clay. Okay. So this is the first graph you need to understand, and secondly is this graph. So that's about it for this subtopic. Now let's go to a more important subtopic, C7, which is on settlement of loads on clay due to primary consolidation. Okay. Previously, we know how to calculate immediate settlement or immediate consolidation. Now we're moving on to the second stage, which is on primary consolidation. Okay, again, the approach is the same, but different formulation is given here. Okay. Now, once the field consolidation line has been defined for a given clay soil, the total expected primary consolidation settlement of the load on the clay can be determined. Now, consider figure C15, where a mass of soil is depicted before and after consolidation settlement has occurred in a clay layer of initial thickness of H. Okay, let's go C15. So settlement of a mass soil, A is before consolidation settlement. So this is before settlement. This is the condition before. And B is after consolidation settlement. So this is by Sherman 1953. Okay. So you need to have all of this in order to make a formulation out of it. So check this. Okay. You have the height, the thickness, before and after, the void ratio, and so on. You're going to do a simple soil mechanic approach in order to get all the respective formulation from C6. We have C7, C8, and C9. I'm not going to repeat this, but you can find this in soil mechanics. Okay, and the most important thing in the end, we're going to be able to calculate the total settlement due to primary consolidation. Okay, how you derive this from basic soil mechanics. And then for this part in geotechnical engineering, you should know the formulation for total settlement due to primary consolidation, which is capital S with a sub C. Okay. Now let's take a note. In practice, the value of initial void ratio is obtained from the laboratory consolidation test, and the value of void ratio is obtained from the field consolidation line based on total pressure. Okay, effective overburden pressure plus net additional pressure due to the structure, both at mid-height of the consolidating clay layer. Please correct this one. The value of H is obtained from soil investigation, which is in chapter 6. Okay. Now, to know more about this, you got to do your design pad. Okay. So this was a previous formulation to get CC. Alright, another formulation, rearrangement, and so on. Okay. Now, apart from calculating settlement due to primary consolidation, you also previously in your lab work has been presented with time rate of settlement due to primary consolidation. This is what you calculated before. So this gives you the time rate of settlement, okay, due to primary consolidation, and it's by Terzaghi and Peck in 1976. Okay, and this also has been discussed in your laboratory sheets, all the important coefficients. And if you look at figure C18, it shows time factor as a function of percent of consolidation. Okay, you have the time here and percent of primary consolidation. So that's all about it in calculating the settlement due to primary consolidation. It's pretty easy. Just use the formulation in geotechnical design pads. Okay. Now we're going to move on to settlement of loads on clay due to secondary compression. Okay. So again, the same thing, but you got to know where is the stage, which is the third stage, which is here. Okay. And I'm going to leave you with a simple formula again. So this one, C25, is the settlement due to the third stage, which is secondary compression. Okay, and it relates to C, coefficient of secondary compression, thickness of the clay layer, life of the structure, and time to completion of primary consolidation. Okay, figure C22 is the coefficient for secondary compression. So a graph or a chart has been established for you in order to get your respective parameter here, which is the coefficient of secondary compression. Okay, you just need to know your natural water content over here. Okay. So C7, C8 is on clay, and now the last part, which is in C9, is the settlement of loads on sand. Okay. Now most of the settlement of loads on sand has occurred by the time construction is complete. Thus, the time rate of settlement is not a factor as it is with clay. Settlement criteria rather than ultimate bearing capacity commonly govern allowable bearing capacity for footings on sand. Furthermore, settlement on sand is not amenable to solution based on laboratory consolidation tests. Okay, so for sand is much more simpler approach. Indeed, settlement on sand is generally calculated by empirical means. Okay, one empirical method is based on the standard penetration test, SPT. Now, to determine the settlement on sand, one makes SPT determination at various depths at the test desired, normally at depth interval of 0.76 meter, beginning at a depth corresponding to the proposed footing base. Okay, this is just the procedure. Okay, and in the end, you are left with equation C26, which is to calculate settlement at the end of construction and application of permanent life load with respect to sand. Okay, and it relates to your footing properties. You have B, width of footing. You also have some relation with the SPT values, which is in terms of N. Q, bearing pressure, and also back to the solve properties, which is effective overburden pressure. Okay. Now, for values of foundation contact pressure less than the pre-construction effective overburden pressure at the foundation base, settlement is given by this. So you have one equation C26 and another equation C27. Okay, some established charts, and that's the end of it. So let's just make a summarization of this. Okay, so in solve consolidation, we have 9 subtopics. So the first part is on laboratory works. Okay, and then for laboratory works, we come up with a field consolidation line. This is an assumption to make a relationship between results found from the lab to actually accommodate for your field settings. Okay, and then we have some simple analysis or formulation equation on settlement of loads on clay due to the second stage, another one due to secondary compression, and lastly the one we have just discussed is an equation on how to calculate settlement of load on sand. So 2 on clays and just 1 on sand. Okay, so any question, please just use the WhatsApp medium. Okay, so that's all about it for this chapter number 3 part 2. To make things clear, please do your design pad. Thank you very much.